Hello students, welcome to Aditya Academy. I'm Dr. Ragini Arora and today we are going to start 8th chapter from NCERT, which is Introduction to Trigonometry. So in this video we are going to learn concepts of this chapter and we will try a few examples to learn those concepts. Now what is trigonometry? It is the study of relationships between the sides and angles of a triangle. So we will study some ratios of sides of right triangle with respect to its acute angles. Now let me tell you one thing. If we have a right angled triangle, let's say ABC is a right angled triangle, right angled at B, right? So now by the angle sum property, we can say that the sum of these three angles A, B and C will be 180. So if this angle is 90 degree, that means the sum of A and C should be 90 degree. That means both angle A and angle C are acute angles. The sum has to be 90 degree. So the individual values will be less than 90 degrees. So in a right triangle, two angles are always acute angles. Now we have to learn that we can take trigonometric ratios of these three sides, any of these three sides regarding angle C or angle A. First, we have to decide what angle we have to choose. Okay, let's see. This is triangle ABC, which is right angled at B. Now, the very first thing is when we have one right angle, the side which is exactly opposite to right angle is called hypotenuse. You must have learned this thing in Pythagoras theorem, but remind this again. The side which is exactly opposite to right angle is called hypotenuse and it is the longest side of this triangle. Now we have two acute angles, angle A and angle C. First we have to decide regarding which angle we are going to take trigonometric ratios. The very first thing is to fix the angle, acute angle for which we are taking trigonometric ratios, because according to the angle only we can define those ratios. So let's say if I am bothered about or if I am taking about this angle A, I am taking ratios about angle A. So this is my preferred angle. So when you decide your angle, now you have to check the angle is between the hypotenuse and one more side. So when it is hypotenuse is always fixed, it is always opposite to the 90 degree. And if you are taking angle A for which you are taking ratios, this AB side will be called side adjacent to angle A. You can see that AB is the side, or you can say that angle A is the angle which is formed between AC and AB. Angle A is formed between AC and AB. So AC is fixed. It is called hypotenuse. The other side in which angle A is involved is called side adjacent to angle A. And the third one is called side opposite to angle A. You can see that here. This side is opposite to angle A. So first of all, you have to define the angle for which you are going to take the ratios. According to that, these two things are designed, whether this is a side adjacent to A or opposite to A, right? So you can see that side opposite to right angle is called hypotenuse. Consider acute angle A. Now we are taking ratios of angle A. For A, side opposite to A is BC. You can see that if A is here, the side which is not in contact with A is opposite to A, side opposite to A. And side adjacent to A, apart from hypotenuse, see angle A is made between AC and AB. AC is already termed as hypotenuse. So AB is called side adjacent to A. I hope this terminology is clear. Now, the trigonometric ratios of an acute angle in a right triangle express the relationship between the angle and the length of the sides. Right? That means if we have 6 different trigonometric ratios, so they are nothing but the ratios of any two particular sides at that time. Now we start taking ratios. See, this is the same right triangle ABC in which right angle is at point B. So the opposite side to B right angle is called hypotenuse. This is hypotenuse. If we are taking ratios about angle A, this is our concerned angle. So side which is opposite to A is BC. See, BC has no contact with A. It is opposite to A. And the sides which include angle A are AC and AB. AC is fixed as hypotenuse, so AB is called side adjacent to angle A, right? Now we have named three sides. BC is side opposite to angle A, AB is side adjacent to angle A, and AC is hypotenuse. Now we define the ratios, right? We have 6 trigonometric ratios: sine A, cos A, tan A, tangent, right? This is sine. The proper name of this ratio is cosine. This is called tangent. This is called cosecant, secant, and cotangent, right? Now, how do we define these ratios? If we are taking sine of A, this is the proper name to this is, these are the short forms of these names. Sine of A is defined as the ratio between side opposite to angle A is to hypotenuse. Side opposite to angle A, if we are taking ratios about angle A, so sine is defined as side opposite to angle A upon hypotenuse. Now in this figure, side opposite to angle A is BC over hypotenuse is AC. Then we go for cosine, which is in short form it is called cos of angle A. That is defined as the ratio between the side adjacent to angle A and hypotenuse. Side adjacent to angle A is AB and hypotenuse is AC. Then we have tangent, tangent of angle A. Tangent is defined as side opposite to angle A, which is BC, divided by side adjacent to angle A, which is AB. Right? These are the three ratios, and the next three ratios are exactly the reciprocals of these three respective ratios. That means cosecant. In short, it is called cosec. Cosec A. Cosec A is the reciprocal of sine of A. It is hypotenuse divided by side opposite to angle A. Exactly the reverse of this. So we have taken AC over BC. Then we have secant, which is called sec of A. In short form, it is called sec of A. This is the reciprocal of cosine or cos. Hypotenuse is to side adjacent to angle A, which is AC over AB. Then we have cotangent. In short, it is called cot A. Cot A is side adjacent to angle A, side opposite to angle A, that is AB over BC. So these are the 6 trigonometric ratios about angle A in this right angle triangle. I hope this is clear. In short, we can write, see, in easy language, I'm telling you again, basic things like you have to remember whatever angle we have chosen, it is always formed between base and hypotenuse. I'm telling you a simpler vocabulary for this. The angle we are concerned is always formed between the hypotenuse, and if we call it hypotenuse, the other side is called base, and the third one is called perpendicular, right? So this is hypotenuse, base, and perpendicular for angle A. If we take angle C, P and B will be reversed. I'll tell you later in the next slide. So if we are right now talking about angle A, hypotenuse is fixed, and the angle we are taking is always formed between base and height. You have to remember base and hypotenuse. So if we are talking about angle A, hypotenuse is fixed, so we treat AB as base, and then BC automatically becomes perpendicular. So in layman language that we have considered, we can say that sine is the ratio of perpendicular and hypotenuse. Cos is the ratio between base and hypotenuse. And tangent is the ratio between perpendicular and base. If it is difficult to learn about side opposite and side adjacent, you can give them another name like perpendicular, hypotenuse, and base, right? So for this figure, for angle A, this is your base, this is your perpendicular, and this is your hypotenuse. So the thing remains same. You can see that sine A is BC upon AC, perpendicular upon hypotenuse. Base, cos is base upon hypotenuse. Base upon hypotenuse, that is AB upon AC. You can see that, right? Then we have tangent. Tangent is perpendicular upon base. Perpendicular is BC upon AB. And these three ratios are exactly the reciprocals of the above three in the respective order, right? So next we go for, now in this figure we are taking ratios about angle C, right? Here this is right angled triangle. Right angle, so the side opposite to right angle is called hypotenuse, which is the longest side in any right triangle. Now if we are considering angle C for the ratios, this BC is side adjacent to angle C. Apart from hypotenuse, this angle C is enclosed between hypotenuse and BC. So BC is the adjacent side, or otherwise you can mark this as hypotenuse and this as base, right? So this side automatically becomes perpendicular. Fine. So now if we come to the ratios, sine of C is side opposite to angle A upon hypotenuse, or perpendicular upon hypotenuse. Perpendicular upon hypotenuse, which is perpendicular is AB upon AC. Then we have cos of C. Cos is side adjacent to C, which is also called base. Base upon hypotenuse, which is BC over AC. Then we have tangent of C or tan of C. It is side opposite to angle C, which is perpendicular AB, upon side adjacent to angle C, which is also called base. So P upon B. And these three are exactly the reciprocals of the above three. So this is how we define. First of all, we have to select the angle. According to the angle, we name these sides as base or perpendicular. Hypotenuse is always fixed. And then we take these 6 ratios in this order. So I hope this is clear now. One more important thing. The values of the trigonometric ratios of an angle do not vary with the lengths of the sides of the triangle if the angle remains same. So you can see that if this angle is a fixed quantity, let's say this angle is 60 degree. So whatever sides you may take, this triangle may be a smaller triangle, this triangle may be a bigger triangle, but if this angle is 60 degree, this angle is 60 degree, the ratio of two sides will always remain same, whatever the values of sides may be. Since it is a ratio for a particular angle, it always remains same, right? Now let us try a few examples over this. This is given tangent of A is 4 by 3. Tan A is 4 by 3. Find the trigonometric ratios of angle A. Okay, now in this figure, first of all, we have to mark them as perpendicular, base, or hypotenuse. In this figure, angle B is 90 degree. So what you can say is, this is hypotenuse, right? Side opposite to 90 degree angle is called hypotenuse. Now what about the other sides? How do we define them? First of all, we have to see, we are taking ratios about angle A, not angle C. So this is our fixed angle. Now what I had told you, the angle we are taking always lies between the hypotenuse and base. So we have to consider AB as base, or side adjacent to A. Side adjacent to A. This is opposite to A. Opposite to A. I hope this is clear now. So first of all, here these sides are given in the form of 3k and 4k. Now in right triangle ABC, first of all we go by Pythagoras theorem, right? Pythagoras theorem is, because we have the values of these two sides AB and BC, AC is not known in this. We have to find AC first. So AC square, hypotenuse square, is equal to the sum of squares of other two sides by Pythagoras theorem. AB is 3k, right? 3k square, and this is 4k square. So we have 9k square plus 16k square. So AC square becomes 25k square. So now if we take the square root on both the sides, AC becomes 5k, right? So now we know the values of all the three sides. This is 3k, 4k, and this is 5k. Now what happens? We are given the value of tangent of A, that is tan A. What is the ratio? What is the definition of tangent of A? It is perpendicular upon base, right? And what is perpendicular? Perpendicular here is 4k and base is 3k. Now we have to find the other trigonometric ratios. We go for sine of A, which is perpendicular upon hypotenuse. What is perpendicular here? Perpendicular is BC. Let me write these. This is base and this is perpendicular. So now I write the ratios here. Sine A is perpendicular upon hypotenuse. Perpendicular is BC upon hypotenuse AC. Perpendicular is 4k. Hypotenuse is 5k. So this becomes 4 by 5. Cos of A is base upon hypotenuse. Base here is AB and hypotenuse is AC. Base is 3k, hypotenuse is 5k, which is sin A upon cos A, and tan A is given to us. Now we have to find other three trigonometric ratios. Reciprocal of sine is cosec. Cosec of A is h upon p, or AC upon BC, 5 by 4. Reciprocal of cos is secant, sec of A, which is h upon B. H upon B, which is AC over AB, and that is 5 by 3. And finally we have the reciprocal of tan, which is cot, cotangent or cot, which is B over P. B over P is base is AB upon P, which is BC, which is 3 by 4. Right? So these are the 6 trigonometric ratios. When one is given, one trigonometric ratio is the relationship between two sides in a right angle triangle. And if we know the values of two sides of a right angle triangle, third can be found by using Pythagoras theorem. That I have done here. And then I have completed all the 6 trigonometric ratios. Next is, if angle B is equal to angle Q are acute angles such that sine B is equal to sine Q, then prove that angle B is equal to angle Q. Now here we have two different triangles in which two angles are given such that their ratios of sines are equal. Then we have to prove that this is the converse of the result that I have told you. If ratios, size of two triangles may change, but regarding one angle, if the angle is same, whatever size you may vary, the ratio remains same, even if the sizes are different. So what do we have to do is, like in triangle ABC and triangle PQR, sine B is equal to sine Q. Now let me mark this. See, if we are taking ratios about B, this is right angle triangle, this is hypotenuse which is fixed. Here it is right angle, hypotenuse is fixed. Then we know that whatever angle we have to take, that angle is formed between the base and the hypotenuse. So if angle B is between AB and BC, AB is hypotenuse, BC has to be base. AC becomes perpendicular automatically. Same is the case in the second. If we are taking ratio about angle Q, this has to be base. This becomes perpendicular, right? So now, what is sine of B? Sine of any angle is equal to perpendicular upon hypotenuse. So in this case, sine of B is perpendicular, AC upon AB. AC upon AB. And sine Q is perpendicular upon hypotenuse. Here perpendicular is PR. PR upon hypotenuse, which is PQ. Right? Now how do we go for this question? This is very important question. Now we have to prove these two triangles similar. So what do? See, I'm taking AC upon AB. So I had told you in the similar triangles chapter also that when we have two ratios equal, the cross product, cross multiplication of these two has to be same. So I'm changing the order, which is called alternando. Like AC, I'm taking PR here and AB here, AB upon PQ. Why I have done this? Now if I write AC upon PR, AC is a side in this triangle, PR is a side in this triangle, is equal to AB. AB is here, PQ is here. What I have done is, by alternating these two values, I have got result of the ratio in the form which can be used in both the triangles. So what happens? The ratio of this pair of sides in these two triangles is equal to the ratio of this pair of two sides in this triangle. Now I have to look for something so that these two triangles become similar. I have to prove angle B is equal to angle Q. For that, I am trying to prove them similar so that B automatically becomes equal to Q. I hope my objective is clear. So now what I do is, in triangle ABC, I'm using Pythagoras theorem. AB square is equal to AC square plus BC square. Right? I have got ratios of these two sides. Right? Now I'm looking for BC square. BC square becomes AB square minus AC square. Right? Now in triangle PQR, apply Pythagoras theorem here. This is PQ square, which is equal to PR square plus QR square. I'm looking for here, I had written the value of PC here QR. So write QR square is equal to PQ square minus PR square. Right? So now what we have to do? See, what we can do is here, AC upon PR is equal to AB upon PQ. Let this ratio be equal to K. Both these ratios are equal. Now what I can do is, I can write AC is equal to K times PR and AB is equal to K times PQ. Got this? This is the ratio. I have used this. Let this ratio be equal to a particular constant K. Now I have written AC and AB in terms of K and PR and PQ. So what I can do here is AB. What is AB? AB is K times PQ. AB is K times PQ minus AC square. Now what is K times K square PQ square? And what is AC? AC is K times PR. K square PR square. Right? So this becomes, if I take this common, BC square becomes K square In bracket we have PQ square minus PR square. Okay, now see what I can do. I already have AC upon PR, AB upon PQ. The third side for which I can take ratio is I have already got AC upon PR and AB upon PQ. Now if I take the ratio of BC and QR and they come out to be same, that means by SSS these two triangles are similar. So I am taking ratio of BC and QR. For BC, this is BC square, this is QR square. BC square is K square times PQ square minus PR square. And QR square is PQ square minus PR square. So what I can do is I can reduce them. So I have got BC square upon QR square is K square. That means BC upon QR is equal to K. Right? This is K. So finally I can write AC upon PR. Let this be 1. Let this be 2. From 1 and 2, AC upon PR is equal to AB upon PQ is equal to BC upon QR. That means in these two triangles, the ratio of all the three sides of one triangle are proportional to the three sides of the other triangle. That means triangle ACB is similar to triangle PRQ by SSS similarity. So after proving them similar, we know that similar triangles have all their angles equal in the corresponding order. So we can say angle A will be equal to angle P, C will be equal to R, B will be equal to Q. So from this we can write angle B is equal to angle Q. These are CPST, corresponding parts of similar triangles are equal. In case of angles they are equal, in case of sides they are proportional. I hope this is clear. It takes few minutes or 2 or 3 attempts to practice this question, but if you understand it properly, it is easier to learn. Next question is, consider triangle ACB, right angle triangle, in which AB is 29, BC is 21 and angle ABC is theta. For simplification, instead of writing ABC, if we are concerned about only one angle, we refer it by theta or phi or some letter. We have to find the values of cos square of theta and sin square of theta. So see, first of all, I am marking perpendicular base and hypotenuse. This is right angle triangle. Side opposite to this is called hypotenuse. Always do this. Initially, you have to do that. So that when it becomes a habit, you can do it without marking these in the figure. This is hypotenuse. Theta is between BC and AB. So hypotenuse is fixed. This has to be base and this one becomes perpendicular. So now for cos of theta is what? It's the ratio between the base and the hypotenuse. So in the figure, base is BC, hypotenuse is AB. Base is 21, hypotenuse is 29. What is the value of sin theta? It is perpendicular upon hypotenuse. Perpendicular here is AC and hypotenuse is AB. And here we haven't found the value of AC here. So first you have to do that. In triangle ABC, AB square is equal to AC square plus BC square by Pythagoras theorem. And now we have AC square is equal to AB square minus BC square. So we have AB square is 29 square minus 21 square. So you can write this as 29 plus 21 and 29 minus 21. This is 50 and this is 8. 8 5s are 40, 400. So AB becomes the square root of 400, that is 20. right? So now we have found all the three sides. We can simply take the ratios and solve them. AC here is 20. AB is 29. So we have to find cos square theta, sin square theta in both the questions. So we have found cos theta. For the first part, cos square theta plus sin square theta is, this is 21 by 29 whole square added to 20 by 29 whole square, which is 441. And square of 29 is 841 added to 400 divided by 841, that is 841 by 841, which is 1. And second part is cos square theta minus sin square theta. Cos square theta is 21 by 29 whole square minus 20 by 29 whole square, which is 441 over 841 minus 400 over 841. This is equal to 41 over 841. Right? So the next question is, in a right triangle ABC, right angled at B, if tan A, here we have to make the figure right angled at B. So we have to keep right angled at B. If tan A is 1, now we are taking ratios about A. Then verify this relationship, 2 sin A cos A is equal to 1. Okay. Tan A is 1. First of all, this is right angled triangle, right angled at B. Side opposite to B is called hypotenuse. If we are taking the ratio about angle A, this has to be base. The angle is considered between the base and hypotenuse, and the third side becomes perpendicular. So now we are given that tan A is 1. Now what is tan A? Tan A is the ratio between perpendicular and base. Tan A is the relationship between perpendicular and base, this side and this side, this and this. So if this ratio is equal, you can say that this is equal to 1. That means perpendicular is equal to base, right? So in right triangle, ABC, by Pythagoras theorem, AC square is equal to AB square plus BC square, right? And here AB, that means AB is equal to BC. Perpendicular is equal to base. So AB is equal to BC. I can write this as AB square plus AB square or BC square plus BC square. 2AB square is equal to AC square, right? What is AC then? Square root of 2AB square. That means AC is equal to root 2AB, right? So if I take it ratio wise, that the ratio of P and B is 1, that means if perpendicular is 1, base is 1, we can take this AC as root 2. 1, 1 and root 2. Since they are equal, and this is AC is root 2 times AB, that means root 2 times 1 is root 2. Now we have to prove. So I'm taking that relationship. LHS is 2 sin A into cos A. I have to prove that this statement is equal to 1. So what is the value of 2? Sin A is what? Sine of A. For A, this is BC. BC over AC. Perpendicular upon hypotenuse. Cos is base upon hypotenuse. Sin A is twice of BC over AC. Cos of A is base upon hypotenuse. So AB upon AC. Right? So what we can do is, I'm just putting those values of ratios. BC is equivalent to 1 in ratio. AC is root 2 regarding that. AB is 1 and AC is root 2. Now you can see that this is 2 multiplied by 1. Root 2 times root 2 is 2. So this is 1, which is RHS. Hence we have proved. And the last question is, in triangle OPQ right angled at P, given that OQ minus PQ is 1, right? So here also we have to mark the sides first. This is right angled triangle, and given that this is 7, PO is 7 and OQ minus PQ is 1. This is right angled triangle, this side is hypotenuse. And if we are talking about sine of Q and cos of Q, that means the ratios are taken about angle Q. If angle Q is the considered angle, then this becomes base. This angle has to be between base and hypotenuse. This is hypotenuse, this becomes base, this becomes perpendicular. So now we are given that OQ minus PQ is 1. So in triangle OPQ, hypotenuse is OQ square. OQ square is equal to PQ square plus OP square, Pythagoras theorem. OP square is 7, right? So we can write OQ square minus PQ square is equal to 7 square. Now OQ minus PQ is 1, right? So we can write this as OQ minus PQ into OQ plus PQ. Apply the identity of a square minus b square. It is a plus b, a minus b, which is 49. Now OQ minus PQ is 1. 1 times OQ plus PQ is equal to 49. So OQ plus PQ becomes 49, and write this equation OQ minus PQ is 1 below this. Now solve this. You get OQ, 2 OQ is 50. So the value of OQ becomes 25, right? And what is the value of PQ then? PQ is OQ minus 1. PQ is, see, this is given to you. OQ minus PQ is equal to 1. So OQ minus 1 is equal to PQ. Now PQ is OQ minus 1. 25 minus 1, that is 24. So all the three sides we have found. This is 7. OQ is 25. And PQ becomes 24. And this is 7. So now we can solve. Determine the values of sine Q. Sine Q is what? Perpendicular upon hypotenuse for Q. Perpendicular is OP. Hypotenuse is OQ. This is 7 upon 25. And cos of Q is base upon hypotenuse. Base for this figure is angle OQ is PQ. PQ upon OQ, which is 24 upon 25. So I hope the basics of this chapter are clear. You only have to stick to the things that I have told you, that whatever angle you have to take, consider that angle between the base and the hypotenuse and treat the third side as a perpendicular one. Then find all the ratios or the values you have to do. And use of Pythagoras theorem is necessary here, because if two things are given, two sides are given, the third you can find with the help of Pythagoras theorem. This is not very difficult topic, very interesting and very easy. I hope you liked this video. Please like, subscribe and share it with your friends. Thank you.